Okay, question 7 is much nicer than question 6. We have coordinate geometry. So, 3 points A, B and C have coordinates 8, 17, 15, 10 and -2, -7. We want to show that angle ABC is a right angle. So, if ABC is 90 degrees, then AB and BC are perpendicular. Now that means that the gradient of AB times the gradient of BC will equal -1. So, let's see what happens. So, the gradient of AB, remember gradient is difference in y over difference in x. So let's do 10 minus 17 over 15 minus 8. So 10 minus 17 over 15 minus 8. Now that's going to give us -7 over 7, which is -1. Let's do the same for BC. So, gradient of BC is going to be let's do 10 minus -7 over 15 minus -2. So we got 10 minus -7 over 15 minus -2, which is 17 over 17, which is 1. Now, -1 times 1 does indeed equal -1. Therefore, the lines are perpendicular and ABC is 90 degrees. Cool. Okay, B part 1 is a cheeky little 1 marker. So A, B and C lie on a circle. We want to explain why AC is a diameter of the circle. So this is going back to GCSE, our circle theorems. Chords that come off the ends of a diameter and meet on the circumference do so at 90 degrees. So because AB and BC meet at 90 degrees and they both come off the ends of AC, AC is a diameter. Part 2 wants us to determine whether the point D -8 -2 lies inside the circle, on the circle, or outside of the circle, and it's 4 marks. So what will determine that for us is if we know the radius of the circle and we know the centre of the circle, if we also find the distance from the centre to point D, if that is less than the radius, it's inside the circle. If it's equal to the radius, it's on the circle. And if it's greater than the radius, it's outside the circle. So, what's going to help us here then is the line AC. We need to find two things. The midpoint of AC is the center of the circle. So, let's find the midpoints of AC. So, let's call it midpoint of AC. Let's call it M. It's the cool thing to do. So, midpoints are the mean coordinates between 2 points. So the x coordinate is going to be 8 add minus 2 divided by 2. Now 8 add minus 2 is 6. 6 divided by 2 is 3. And then for the y, we're going to do 17 add minus 7, which is 10. 10 divided by 2 is 5. So the midpoint coordinates, or the center of the circle, are 3, 5. Okay, next up then, let's find the length of AC, which is the diameter of the circle. So, AC is going to be the square root of, so, let's see, what's the length along x? So, 8 and minus 2 have a distance or a difference of 10. So our length along x is 10. So it's going to be square root 10 squared. And our distance, our vertical distance, is between minus 7 and 17, which is 24. So we got 10 squared add 24 squared. Now that, I believe, is going to give us, well, 10 squared is 100, 24 squared is, let's just work it out. So 24 squared is 576. So this is the square root of 676, which I believe square roots. Yes. So the square root of 676 is 26. So the radius is 26. Okay, so now we need to find the distance between the centre, which we've called M, and D. So, MD, very similarly, is going to be the square root of, while D has coordinates minus 8, minus 2, M has coordinates 3, 5. So the distance between the x coordinates is 11. and the distance between the y coordinates, so between -2 and 5 is 7. So that gives us then the square root of 121 add 49, which is the square root of 170. Now if we work out what that is roughly, it's not a square number, so the square root of 170 is just over 13, literally just over. So I'm actually just going to say that that is greater than 13. So MD is greater than the radius. Therefore, D lies outside of the circle. Cool.